Hello everyone. If you haven't subscribed to our channel yet, then subscribe to this channel. The secrets of dark openings in the immense region of the universe where light curves and time stops lies one of the most mysterious peculiarities known to science, dark openings. These infinite behemoths, brought into the world from the passings of monstrous stars, have gravitational powers so strong that not even light can get away from their grip. However, in spite of their significant importance in how we might interpret the universe, dark openings remain covered in secret, their mysteries tantalizingly unattainable. The account of dark openings starts with the existences of stars, those divine monsters whose brightness enlightens the night sky and powers the infinite show unfurling around us. Brought into the world from tremendous billows of gas and residue, stars are the motors of creation, melding hydrogen into helium in their centers and delivering immense measures of energy all the while. Yet, the excursion of a star is a dubious one, laden with difficulties and hindrances that can shape its fate unexpectedly. For most stars, this excursion closes unobtrusively, as they shed their external layers and blur into the cool obscurity of room. However, for a chosen handful, the story closes in a terrific blast of greatness, a cosmic explosion blast that lights up the night sky and eclipses whole universes for brief minutes. Whenever a monstrous star arrives at the finish of its life, it goes through a devastating breakdown under its own gravity, compacting its center into an endlessly thick point known as a peculiarity. Encompassing this peculiarity is a region of space-time known as the event horizon, a limit beyond which nothing, not even light, can escape. This is the introduction of a dark hole, an enormous chasm from which nothing can return. When caught inside the event horizon, matter and energy are unyieldingly drawn towards the peculiarity, where they are crushed into oblivion by the enormous gravitational forces at play. However, while the fundamental properties of dark holes are known, many mysteries remain unanswered about these enormous peculiarities. One of the most fascinating questions surrounding dark holes is the nature of the singularity at their centers. What happens to matter and energy once they pass beyond the event horizon? Does the singularity represent a true breakdown of the laws of physics, or is there a deeper explanation waiting to be discovered? Another mystery surrounding dark holes is their role in the evolution of galaxies and the universe as a whole. Recent observations have revealed that supermassive dark holes, with masses millions or even billions of times that of the Sun, lurk at the centers of most galaxies, including our own Milky Way. These massive behemoths are believed to play a significant role in regulating the growth and development of galaxies, influencing the formation of stars and the distribution of matter throughout the universe. However, how do supermassive dark holes form, and what processes govern their growth and evolution over immense time? These questions have spurred a wealth of theoretical and observational research aimed at unraveling the mysteries of dark hole formation and dynamics. Furthermore, the study of dark holes has significant implications for how we understand the fundamental laws of physics. Dark holes represent extreme conditions where the effects of gravity are pushed to the limit, offering unique insights into the nature of space, time, and matter. For example, the study of dark hole thermodynamics has revealed surprising parallels between dark holes and traditional thermodynamic systems, suggesting a deep connection between gravity and the fundamental laws of thermodynamics. Similarly, the study of dark hole entropy has shed light on the nature of information and the ultimate fate of information that falls into a dark hole. However, perhaps the most tantalizing mystery surrounding dark holes is their potential connection to the deepest questions in theoretical physics, such as the nature of quantum gravity and the unification of the fundamental forces of nature. Dark holes provide a natural laboratory for testing the predictions of quantum mechanics and general relativity in extreme gravitational fields, offering insights into the nature of the universe at the smallest and largest scales. As astronomers continue to study dark holes and unravel the mysteries of these cosmic enigmas, new discoveries await us just around the corner. From the discovery of new types of dark holes to the exploration of their interactions with their surrounding environments. The study of dark holes promises to transform how we understand the universe and our place within it. Ultimately, the tale of dark holes is a testament to the power of cosmic forces and the wonders of the natural world. By delving into the depths of space and unraveling the mysteries of the universe, we gain a deeper understanding of the cosmos, as well as a greater appreciation for the beauty and complexity of the natural world. And as we continue to explore the mysteries of dark holes, we are reminded of the boundless potential of human curiosity and imagination to unlock the secrets of the universe. Thanks you for watching.